The Earth is rich in about 1.30 billion cubic kilometers of seawater. Bucket of water in the ocean. This looks like a bucket of seawater. In fact, rich micro-ecosystems. This reminds us, infinite miracles in the vast universe. The grand scheme of the universe. Our exploration is just a tiny fragment. However, have revealed dozens of potentially habitable Earth-like planets. Today, we will explore in the mystery of the most promising Kepler universe and imagine life on a completely alien planet. In the search for potentially habitable planets, scientists prioritize findings that are very similar to our Earth. The first thing to focus on is those that are similar in size to Earth, with rocky surfaces. In addition, the planet must be around the size similar to our Sun orbit. At the same time, its orbit remains within the habitable zone. 2b was the first to be discovered, orbiting Sun-like stars. It would be an ideal candidate for habitability. Scientists believe that Earth-like planet ever discovered. And there's a reason for that. Kepler 452b, orbiting a giant star like the Sun. Although this star is brighter than the Sun, slightly larger, but 1.50 billion years older than the Sun, received by Kepler 452b than the Earth. Its volume is 1.6 times that of the Earth. 50% chance of being a rocky planet. The orbits of these two planets are also very similar. Kepler is also located in the habitable zone of its star system, farther than the distance between the Earth and the Sun. Compared to Earth, Kepler 452b during its life have a valuable advantage because it spent 6 billion years in the habitable zone. This planet has the right conditions for life. Scientists have discovered that satisfies some of those conditions. It shows that if the concentration of carbon dioxide in the planet's atmosphere is similar to Earth, then this planet would be habitable. So what would life be like in this world? Due to the fact that this planet is more massive than the Earth, therefore, its surface gravity may be stronger. Environment. People need to get used to their bodies that are twice as heavy. First, people would have a hard time even walking. But over time, we will gradually adapt, paving the way for the process of natural evolution. Firefighter carrying a heavy load. Our bodies adapt to new environments, get stronger. By increasing physical activity, our bones build resilience, able to resist the attractive forces pulling us to the ground. After a few generations, we'll be born with a strong constitution. This would significantly exceed the constitution of a newborn baby on Earth. Kepler is harvesting energy from stars. Surface temperature will be more like. It still relies on photosynthesis as its main energy source. Scientists also this planet may have a thick atmosphere, liquid water, and active volcanoes on the surface. Predictions are correct. Kepler R452b could be a power candidate for Earth 2.0. For long, researchers believe that this planet could be in about 500 million. Experiencing the runaway greenhouse effect, dioxide levels skyrocketed, caused Kepler to resemble Venus, a scorching world. Fortunately, it 500 million years to establish a home on this planet. It's very exciting, but it's not the only promising migratory planet, and it's 1,800 light years from Earth world. But if we take the fastest man-made object ever created, Parker, the solar probe can reach a speed of 190 kilometers per second. But it's still only 6/10,000 the speed of light. Even such a fast detector still 2.80 million years from Earth. 452b. Constellation Cygnus, 500 light years from Earth. Dwarf star. This celestial body. Scientists have discovered 1 planets in the habitable zone. Kepler 186f. And astronomers have multiple Earth-like planets in successive universes. And there is liquid water on the surface. Kepler 1862 was less than 1/10 the size of Earth. Planet is 130, located on the outer edge of the habitable zone, 1/3 of the heat of the Earth. It looks more like Mars, but this difference is not unfortunate. It gives them a unique advantage. Red dwarf flares tend to be more intense. Sometimes it suddenly doubles in brightness, even though this star is less massive and cooler. Brightness is not high. M-type star. There are also frequent bursts of intense radiation because Kepler 1862 is far enough away. This deadly radiation create the conditions for life, not only on the distance to the stars, and the water resources. Kepler 186 means there may be frozen water on the surface. Its greater volume could have an atmosphere denser than that of Earth, be retained and dispersed, and melts ice water of the other 4 planets in this star system, half the size of the Earth, and they have very short orbital periods. This makes it very hot inside. Existence unsuitable for life. Solar probe to reach Kepler 1868, 780,000 years, entered one in the future, a spacecraft traveling at 90% the speed of light. After about 550 years, descendants will set foot on the land of Kepler 1.86 million light. The planet orbits a red dwarf star, smaller than the Sun. It's 25 times dimmer than the Sun. If you stand on Kepler 1862 during the day, look at this red dwarf star. The scene you see is like the afterglow of the setting sun. It means a steady axial inclination to have regular climate movements. Seasons change, like on Earth. Expected, remain stable for tens of millions of years. This is crucial. An unstable tilt could have catastrophic consequences. Potentially habitable planet into a barren world. Think Mars is an example of unstable axis tilt. Search for habitable planets continues. Some instance candidates are usually discovered by chance. 1649C was accidentally discovered during an observational inspection. Scientists still know very little about the world, including its atmospheric composition. Preliminary judgment. Energy received by Kepler 1649c, 5% of the Earth, and because it has an orbital period of only 19.5 days to the temperature we have on Earth. It lacks an atmosphere to trap heat. Its surface temperature will be about -39 degrees Celsius. No greenhouse gases. The surface temperature will also drop to -18 degrees Celsius. Kepler 1862 still needs more greenhouse gases. In the universe, there are many other worlds similar to Earth. And these Earth-like planets are much closer. Look at it now. Reaching Kepler 1649c seems out of reach because it's 300 light years away from us. But then I remembered, it will be a worthwhile journey. Because of the above planets and relate to Kepler, the unique advantages of the 1649c are comparable, not only in terms of temperature and size, and in the habitable zone of its star. It was an extraordinary discovery. The star system also has a second planet named Kepler 1649b. Its size is 8% larger than that of the Earth, the red dwarf, due to the fact that the orbital period ratio of the two worlds is 4:9. It will contain a third planet. Soon after, the next generation of observatories will provide us with more clues. A distance of 1,100 light years. This is Kepler. It orbits a K-type star. Its orbital period is 112 days. Distance is half the distance between the Sun and the Earth. Many problems for life. Usually, close planets are tidally locked to their stars. This results in a very harsh environment on the surface. Kepler 42b's attractive force in the star, the range of tidal locking compared to the Sun. Type stars are usually dim. This is a smaller, cooler star. Therefore, Keple R442b happens to be in the right place. K-type stars are the best places to find migratory worlds. They are not as bright as giant stars, not as long-lived as M-type red dwarfs, provide a powerful combination of features. Within 100 light years of our Sun, there are at least 1,000 K-star stars, and is between 1.50 billion and 4.50 billion years. Over the brightness of dust dwarfs only increased by about 10 to 15%. Same time, Sun in just 10 to 2 billion years could make the Earth uninhabitable. So what's the future of Kepler 42b? Astronomers like to consider the potential habitability of planets. They use a method of comparing the livability index to classify of things to consider, including the composition, size and temperature of the planet, and orbital inclination, etc. It measures the energy of a star reflected by a planet. These comprehensive play an important role in determining livability. even in the case of irregular planetary orbits. Same thing, same as the Earth Similarity Index. Compare the livability index on a scale from 0 to 1. Indicate higher livability. According to these standards, 4.2b scored 0.84. Planet is too faint and too small, able to image directly with our existing telescopes. Travel to it. Even though the Parker detector 1.70 million years to arrive. What we can do is observe its ecology of habitable planets. Study of radiation levels, stellar radiation received by Kepler 4.2b. Webb Space Telescope detected. Meanwhile, this telescope, habitable planets can be observed. Among them, Kepler 621 and Kepler 62 are the largest habitable zone. The remaining 3 planets close to this K-type star, causing them to overheat, suitable for sustaining life. 621 and Kepler 622 are rich in water. 8.3 and 0.69, respectively, billion orbits the star. Kepler 62f has an orbital period of 267 days. Billion has thick clouds, constantly warm and humid climate. This climate even extends to the polar regions. Conditions a supportive environment for life. A study shows that there may be a satellite 6.20 billion Kepler. If so, the planet will be more habitable, because satellites are necessary for the evolution of complex life, as tidal forces, rotation and tilt of the planet. This has a direct impact on its climate patterns and also act as shields, absorb the threat of asteroid and comet impacts to protect life on the planet. Kepler 62f is far away, cooler, but he still has the potential to survive. Although Kepler 621 and Kepler 62 it is not the ideal twin Earth today, but the changing nature of planetary systems is to revolutionize these worlds. Our planet was once completely submerged in oceans, but over time, it becomes a diverse world of land and water. Researchers think the future development of these exoplanets, it is speculated that they may also eventually evolve into. At the same time, even on Earth, we also have strange creatures like flying fish. Suppose there's life on these Earth-like planets. They can be very complex. This is not unreasonable. One of the greatest challenges in studying these worlds. Distance. However, not have to wait for a more advanced telescope of this problem. The data from the European Space Agency shows that sun-like stars in the universe, 50% chance, potential to migrate to a rocky world, may be lurking near us. This means that within 20 light years of us, there is a 95% chance that there is at least one